So, a student studying a public policy created a model for the population of Detroit where the population decreased by 25% over a decade. So, if something decreases by 25%, instead of having a full 100%, we would only have 25% less. So, out of 100%, we would know that 75 would be remaining. So because it's a population decrease of 25%, what we're actually looking for is a 75% remainder. Okay, so that's why there's a 75 in here, or 75%, instead of 100% or even that 25%. We decreased by 25%, so we kept 75%. Come to think of it, why would there be a 714 in the front here? Well, that's the initial population after, 0 decades of waiting. So we can use that in Suzanne's model. So Suzanne wants to use a model that would predict the population after Y years, not D decades. So that's a big difference. A decade is 10 years. Well, Suzanne actually has the initial population of 714 down correctly. So it's going to be a matter of what are we putting on the inside. So what are we putting on the inside of our parentheses instead of 75%, like when we use 75% for decades. That's a big difference, decades compared to years. Alright, so instead of having the 0.75 in the middle, what we would actually need is 1/10 of that. We simply take the 0.75 from earlier, and since one decade, since 1 year, since 1 year is 1/10 of a decade, we would have 1/10 up top. So what we'll need to do is go to our scientific calculator and do 0.75 raised to 1 divided by 10, or 1/10. And we get 0.9716 and a bunch of stuff. 9716 and a bunch of stuff. So we have a 9716, 975, nope, so that's a no. This is not even a 97 anything, and same here. So it's going to be choice C. Now for the bottom problem, the zeros of this function here are, the easiest way for me is to simply factor it. So let's open up a couple sets of parentheses. Load the fronts with x's, because we're just going to x squared. Now the minus means we're going to have opposite signs. So it doesn't exactly matter which goes in where, because the fronts are just x's, so there's a symmetry there. Now what this minus sign by the 2 indicates is that we're going to subtract to 2. So we're going to multiply to -24 and subtract to -2. So the simplest way to figure these out is to multiply to -24. We could have something like a 1 and a 24, or a 2 and a 12, or possibly a 3 and an 8. How about a 4 and a 6? And would 5 work? Well, 5 times anything won't be 24, so 5 won't work. And then how about 6? Would 6 times anything be? Oh, 6 times 4, we already have that with a 4 times 6. So that's how we know we found all our pairs. Now, the last thing we want to do is subtract to -2. So subtracting to -2. I think 4 and 6 would work because they're 2 apart. how about 3 and 8? They would subtract to something like 5 or negative 5. 2 and 12 would be like 10. And 1 and 24 would be like 23. So, you know what? I bet it's going to be the 4 and the 6. How about we make the 6 negative and we make the 4 positive? This would indeed work because we would have, 4 minus 6, and that would be way below 0 at negative 2. Now, the only thing that's left to do is figure out when these equal 0. If we had a negative 4, or the opposite of 4, we would have negative 4 plus 4 being 0. So negative 4 is a solution here. And you know what? That already makes it choice C. Also, if you wanted the other one, instead of negative 6, you would just have the opposite of positive 6. If x were positive 6, then we would have 6 minus 6 equals 0. That is indeed correct. So choice C is our winner.